Right, good afternoon. I am going to start very promptly because we've only got 20 minutes for this session and I really do want to get as much use out of the time as possible. In fact, the session's so short that once I put the presentation together and I ran it a couple of times, it was very apparent that no matter how fast I talked, I wasn't getting anywhere close to getting through all the material. So what I've done is take that material, that's the version that's on the event app you can download. What I've done today is try and boil each slide down to just a couple of points, the kind of Cliff Notes version of the whole thing, just to give you a pointer to where to start looking, where to start thinking about. And if you're interested, go back to the main event app, come and talk to us, and we'll be able to give you the detail. Okay, so let's get started. My name is Wright. I've been with InterSystems for a long time, 23 years, I think it is now. I started out as a sales engineer here in the US. I was a sales engineer for about 10 years, moved back to the UK to work on the initial rollout of TrackCare with some of my colleagues here in the front row. Happy days, not so much. And for the past 8 or 9 years now, I've been in the technology architect group, and our focus is on performance, reliability, scalability of all our products on all our platforms. So we're data platforms, we're TrackCare, we're HealthShare, we're Health Connect, we're cloud, we're on-prem, we're virtualized, we're bare metal, all of those things. And we've kind of been taking that view of our AI work for the last 8-9 months or so. So that's my perspective. That's how we've got to where we are today and why I'm giving this presentation. I'm not even going to go through the agenda. I'm just going to start into it. So I'll be stating the obvious if I say to you that interest in generative AI has taken off over the last 18 months, right? Since OpenAI released ChatGPT in November 2022, it's in the public consciousness, and it's also something that all companies are now thinking about. I think it's true to say that practically every company is thinking, how can we use generative AI? How can we use it to be a differentiator? How can we use it to add value to our business, right? And I think that's going to expand and continue, and I think we're going to see more use cases develop in the short term, medium term, and in the long term. It's important to note, though, that what we're talking about here today is generative AI from an InterSystems perspective rather than industry perspective. Why is that important? It's important because our experience is really limited to a subset of use cases. Time has not started, so I've no idea how long I've been speaking for. Okay, the subset of use cases, right? And that subset of use cases is three things, really. It's things we've built internally ourselves for use in our business. So an example would be the AI-driven chatbot that we've developed for support. You might have seen that referenced in other presentations today. Second thing is the AI-driven functionality that we're working on adding to our applications, like TrackCare, like HealthShare, like the TrackCare AI assistant that you'll see talked about tomorrow, I think. And the third part of that subset, that population, is applications that you've developed, right? Or you are developing, both our users and through our developer community innovation program, right? So that's another feed of things into the way we're talking about. Important to say that all of those use cases tend to follow a similar design pattern, one design pattern. They tend to be assistant-based. They always have a human in the loop who's going to mediate and interpret the AI-generated content. They add domain expertise to the generic behavior of the language model by using RAG rather than fine-tuning, retrieval augmented generation. And they're all more or less that type of thing. So that's what we're talking about today, but we'll also talk about where that's going to go in the future. Okay. So before you can deploy something, obviously you have to build it. So let's take a quick look at the pieces that we have to build before you have a generative AI application. For every interaction that you make with your generative AI application, you have to capture that interaction in some sort of user interface, right? Be it a chatbot, be it a constrained prompt or whatever. You need to orchestrate that iteration. So you need to use something like LangChain to chain together all the component pieces. Right? You need to build a prompt. You need to build a prompt that's going to guide the language model at the inference step to give you an answer that's relevant and dependable and appropriate to what you've asked it. Pre-trained language models give you a generic behavior, right? And that generic behavior is derived from the data they're trained on. So at the moment, the leading large language models are trained on the contents of the internet. So you get a generic behavior up to the point that training happened, right? But typically you'll want to add application domain expertise to that when you build that into your business. There are two ways of doing that. One is to fine-tune the language model. That's to take a pre-trained model, take your data, and run a second training step. Okay, that changes the weights inside the model so that the responses are more appropriate to your application rather than a generic application. Right? And that's okay, but it's resource intensive. Even that second training step needs a lot of resources. And the other thing is it risks data leakage. Okay, you're using that data to train another model. How do you stop it going anywhere else? Right? And the other thing is obviously that it's the same issue as it is with the pre-trained language models. They're up to date when you've trained them, but any new information you add from then on doesn't get incorporated unless you do another training step. Second way of doing it, the one that most of these use cases that we've seen so far use, is retrieval augmented generation. I know lots of people have talked about that today. It was in the keynote and so on. The way that works is to take domain-specific data, and what you want to do is take domain-specific data and find domain-specific data that's meaningfully, semantically related to the question you want to ask your generative AI system, and include that in the context when you make the prompt call. Okay? To drive that lookup, you take your unstructured data, you use an embedding model to generate a vector, a mathematical representation of that, a vector embedding. You store that vector embedding in a vector database, and then at lookup time, you take your input text, you perform the same vector embedding step on that, and then you can find the vector proximity to the vectors you've already got embedded, and then use a vector proximity function to return the vectors of the most appropriate data. Select the top 5, the top 10, whatever way you want to do it. Include that in the context that you're then going to pass into the language model at the inference step. Okay. I talked about text. It's not just text. If you've got the right embedding model, it works with audio, it works with video, it works with images, and so on. So when you come to think about building a generative AI solution, what do you need to think about? Well, your first decision is whether you're going to use a proprietary platform or you're going to build it yourself with a tools-based approach, best of breed kind of thing. Fully managed proprietary platforms are available for the big cloud service providers. So Amazon have something called Bedrock, Google have something called Vertex, and Microsoft have Azure AI platform. Okay, these platforms offer you a single integrated development and deployment environment, choice of language models, choice of RAG tools, choice of orchestration tools, and a choice of language models. Right? It's important so they're built on the cloud service provider's infrastructure, and they can leverage the performance, scalability, resilience of that cloud service provider's infrastructure. Okay, and they also have a security and compliance framework built into them. Okay, that security and compliance framework is probably not going to address all of your concerns, but at least give you somewhere to start with to build out what you do need to address all of your issues. Okay, the downside, that sounds good, right? The downside of it is that you risk vendor lock-in. You risk vendor lock-in to their technology and to their pricing, and again, the other thing is if you're doing a RAG model, you're going to have to take your data to the cloud to work with it. So you're going to have to take your data off-prem, you're going to have to put it in AWS or Google or Azure and work with it there. That's expensive, and it again risks data leakage. It's a potential security issue. Okay, I don't know if any of you were in the session that the guy from Cisco did first thing this afternoon. If you weren't in there, download his slides and scare the crap out of yourself about all the potential risks that there are in doing these kind of things. So the alternative to doing that is a tactical approach, right? So you're going to use best of breed tools to build all these components, and you're going to use an orchestration tool to chain them together. The LAN chain is the one that most people are familiar with. In that scenario, IRIS could give you some significant benefits, right? Firstly, the ability to leverage the vector support that's now in IRIS to do the RAG step close to the data in an environment that you control. Okay, you don't have to move it to the cloud. And the other thing is that if you're doing that RAG step close to your application, you have the ability to leverage all the other parts of your application to make that RAG step better. So you can use structured data, you can use other information you have available in your application, combine it together, make sure your context that you're passing to the prompt is as good as it can be, because that's what's going to dictate how good the answers are. Okay. So what have we seen? We've seen a full spectrum of everything from built in a proprietary platform to people thinking about how they can build more and more of this in IRIS. And the spectrum really is time sensitive. The first things that we developed in-house, like the support assistant, were developed on the proprietary platforms. For example, Yoki, the support assistant, was developed on GCP Vertex. Now, you're going to ask me, well, why didn't you build it in IRIS? Simple answer is that we started building it probably 18 months ago now. 18 months ago, we didn't have the tools in IRIS that we could use to make that work. I think you'll see that pretty much across the board. It's personal experience would say it's a quick process through a proof of concept using these kind of tools to make it secure, scalable, reliable, etc. It is not a quick process. It's a months, years type process. So we built that on GCP Vertex because the tools weren't available in IRIS. That's changed with the release of IRIS 2024.1. Vector search is now offered as an extension to our multi-model database engine. It's a key enabler for building RAG applications or the RAG component of your AI solution in IRIS. Using embedded Python, you can import the embedding model of your choice. You can run that against your data. You can use a simple insert to store that data in the IRIS database, and then you can use our proximity functions to find the vector proximity of your input text to the stored data, retrieve that data, package it up, and include that in your prompt. Okay. One other thing you can do if you're working with IRIS, you can work with IRIS interoperability. My colleague from Germany will be talking about that in much greater detail in the next session. So if you're interested, stay in the room and listen to that. So in terms of development, you have a lot more flexibility now than you had if we'd done this session when we were in Florida last year. And I think that flexibility is going to increase as time goes on. We're already seeing that. 2024.2 that we're working with internally improves the performance of the RAG step. It does that by optimizing the performance and storage footprint of the vector operations, and it does it by adding new functions that you need for building a RAG. Stuff like data chunking. If you're building a vector representation of something, you want a reasonably sized piece of data. So we now have a data chunker that chops your data up, which comes from a PDF or a Word document, whatever, into appropriate sized pieces that you can then use to run through your embedding model. So to net that out, design choices will dictate your deployment options, the options being to build on a platform or build it best of breed. Build deploy is the simplest, proprietary platform is the simplest way to do it, but you risk locking. Building significant parts of your solution in IRIS is an option beginning in 2024.1, and the available tooling is going to improve as things move forward. Whichever your method you choose, you find out very quickly when you start working with this stuff that calls to language models are slow and expensive, and they're likely to remain so. They're expensive in terms of the compute you need to service them, right? There's a reason that NVIDIA are the second largest company in the world now by market cap. They're expensive in terms of the resource required to run them, and they're expensive in terms of the actual dollar cost. If you've got a heavy interaction that you're calling these LLM engines for multiple times with a long context, the actual dollar cost of doing that is going to rack up very, very significantly. Okay, so it's worth thinking about. It's worth thinking about the cost. Do you need the behavior and the cost of one of the leading proprietary language models, or can you make do with something smaller, lightweight, that needs less resources and is probably cheaper to run? Okay. So, what are the things you need to think about when you start building? Are you feature function constrained? Is there something that you need to do that can only be done by one of these tools? Okay. Typically, you're going to think about the language model first, but it's applicable at all levels of the stack, right? It's absolutely true to say that the leading proprietary language models like GPT-4 are the market leaders in terms of functionality and so on, but they're expensive, and don't assume that you need all that functionality before you understand your use case. It could very well be, especially if you've got a constrained use case, that you can use a cheaper, lighter weight, less resource intensive language model, and it will work for you just fine. It's also worth remembering that, as well as the language models that you're familiar with through the general press, there are also domain-specific language models that might be a better fit for your particular application. So there are language models in finance like Bloomberg GPT. There's one in medical domain, which is called MedPalm from Google, and so on and so on and so on. Okay, so look at those two. How do you go finding out about that? Well, there are a lot of comparison sites out there. Everybody's thinking about this now. If you type LLM dashboard into Google or Bing, you can use AI to find out about AI. That will tell you, give you a whole list of data of sites where you can go and start finding out about this and finding out what's appropriate to you. Are you cost constrained? Okay, or more realistically, how cost constrained are you? As I've said, proprietary language models charge typically on a per-use basis, and the per-use cost escalates as the context, the amount of information you pass into it, gets longer. So basically, the more complex the call you're making, or the more complex the context of the call you're making, the more it's going to cost you, and that can rack up quickly. These AI interactions are typically iterative, in the AI jargon, multi-turn. So it's not just one call, it's one and another and another. That's why you use an orchestrator like LangChain to keep track of those and pass it on. So think about that. Do you have a skill set that you can leverage when you build your AI solution? Good AI expertise is vanishingly rare and exceedingly expensive in the skills market these days. But it's not unreasonable to think that, as we're all at Global Summit, if you develop, deploy and manage at least part of your AI solution in IRIS, you can leverage skills that you already have in-house. And same thing, level down the stack. If you're an AWS shop, might make sense to use Bedrock. If you're a Google GCP shop, might make sense to use Vertex, just to leverage those skills that you've already got. Okay. What are the limiting factors? Well, over the last several months, I've sat in a whole lot of presentations and meetings. Nobody's worrying about performance yet. Nobody's worrying about availability yet. I think that's going to change. I think it's going to change for two reasons. One, generative AI is not baked into people's business yet. We're still early in the curve, right? We're still at the beginning of how we're going to use this. As it becomes a key part of your business, I think it's going to be subject to the same constraints as the rest of your business. It'll have to have the same availability, the same performance, and so on. I think the second part is that we're going to drive use cases closer towards the application. At the moment, nearly all of the use cases are driven by user interaction. I think we'll see use cases driven by system interaction become more important, right? So you can imagine something where instead of a user asking a question, you want to perform a generative AI operation on the contents of a message you're receiving in interoperability production. For that, you can't use the model we're using at the moment. It's too slow, it's too expensive. So you have to come closer to the data, closer to the application. And you have to look at, like I say, lighter weight ways of doing things. Okay, I can see the light flashing. I don't have time to go through the examples, but they are in the slide deck that's downloadable. So to wrap up, perhaps editorialize a little, I think I'm fairly safe in saying that the generative AI space will continue to be a volatile one. There are significant events already on the horizon. I don't think the exponential change we've seen over the last 18 months is likely to continue. I think the changes will be more incremental. So I don't think the GPT-5 will be the quantum leap that GPT-4 was over GPT-3. Okay, but things will continue to change. I think the use cases will continue to expand, and as I've said, migrate close to the application. One thing I think I'm very, very safe in saying, that when we stand up and do this again next year, everything will look different, and there will have been changes that we didn't possibly anticipate, right? So, you know, you've got to be agile, you've got to be lightweight, and you've got to scale your thinking appropriately to that time frame, okay? So it's not just IRIS. One day, quite soon, it could be, but at the moment it's not. You have to think about a lot more things and a much bigger picture. Okay. Don't have time for any questions, but I'll be around for the whole week. You can get hold of me, I think, through the event app, or come up to the Tech Exchange. We're all the InterSystems technical people are contactable through the people there, or I'll be hanging around out here if you do have any questions. If you're interested in this, look at the early access programs, specifically the Python piece and the vector search piece. Python is the lingua franca of AI development. You've got to learn Python if you want to do this stuff. Look at that, look at vector search, take the survey, and think about what you're going to do with AI, whether you too are going to welcome our new robot overlords. Okay, thanks very much, and any questions, come and talk to me afterwards. Thanks a lot.